go. This is Conroy and Ryan Dooley, and this is our Chapter 9 presentation on sampling distributions. So parameter versus statistic. A parameter is a number that describes the population, and it's usually a Greek letter, so it would be mu, sigma, or rho. And statistic is a number that describes a sample, and that's usually English alphabet, which is X bar, S, and P hat.
So variability and bias. Variability of a statistic is described by the spread of its sampling distribution. It's how far apart the points are, or data. And bias is a statistic used to estimate a parameter, and it's unbiased if the mean of its sampling distribution is equal to the true value of the parameter being estimated. So these are some graphs that show different types of variability and bias. And you can see that in the top left that when it's a low bias and low variance, the points are in the middle, which is the bias part, and low variance are the points are clustered together. Top right, high variance, the points are spread out, but they're relatively close to the center. So they're low biased. Bottom left, it's high bias because it's not near the center of the graph, but low variance because they're clustered together. And bottom right, high bias and variance because the points are not close to the center and they're scattered.
So to describe a distribution, you can use four different things, which include shape, center, spread, and outliers. So shape, as in like this graph, you can see it's a unimodal graph. So there's one mode and it's just normally distributed. The center it can determine if there's any skew. For the spread, that's how far spread out the data is. And outliers, see if any outliers affected your data and what effects that could have.
Okay, so 9.2 formulas. You can have p hat, which is the number, which is described by x over n, which is x is the number of successes, whereas n is the number of observations in the sample. And then you have the mean of p hat, which is also equal to p. And then you have the standard deviation of p hat, which you can see by this equation right here. And there's two rules of thumb. One of them is that the population has to be greater than 10 times n, and the population, which is n, has to be large enough to make sure the normal approximation is accurate. And the accuracy of the normal approximation increases as n increases because the more observations you have, the more accurate the sample will be. And the second one is p hat is equal to n if n times p is greater than 10. And the same goes for the failures, which is n multiplied by 1 minus p hat.
So in 9.3, we learned that the standard deviation of the sampling distribution x bar is sigma over the square root of n. So the central limit theorem is if n is large enough, the sampling distribution of x bar is approximately normal with a mean sample standard deviation regardless of the shape of population distribution, and the mean is equal to mu.